Hey everybody. Are you a content creator who's struggling with your audio processing? Or maybe you're just overwhelmed trying to figure out a process. If that's you, this video is for you. I'll discuss how I approach the audio that I produce and the order that I've found tends to work best for most dialogue recordings. The topic of this video was suggested by a commenter on one of my videos, and I do apologize for not remembering your name, but this video is for you. The first thing I need to say is that there aren't any rules, and this is all based on my experience in both music and dialogue production. There are really kind of two different situations here. Either you're producing your own audio or you're producing someone else's audio. Either way, the process is going to be similar. The real difference is going to be that when you're producing your own audio, especially when you record in the same space with the same equipment each time, you'll be able to really set up templates and presets that work for your setup. So it becomes almost a drag and drop type situation. When we produce for others, though, there's a lot more variety to the recordings and to the quality. So we end up spending a little more time assessing and determining what the audio needs. Let's start with the order of operations. This will probably be the most important part, and while there aren't any rules, there are some best practices here. So let's take a look at my kind of ideal order of operations. And later in this video, I'll show you my actual order of operations because it will be a little bit different from this. Loudness, assess, repair, cleanup, frequency balance, dynamics, loudness. The first thing I do when working with audio is I want to increase the volume to what I call a workable volume. These days, that's handled in my DAW, which is Hindenburg, and it automatically applies loudness normalization to every file I bring into it. Most other editing software will have loudness normalization. Some will call it by other names, but you should be able to find out if your program of choice offers it with a simple Google search. But do keep in mind that not all programs offer this feature. Where you perform this step in your process really depends on your specific workflow. In general, it should be the last step of your processing before bringing audio into your DAW, or it's the first step once the audio is inside your DAW. For instance, when I was working in RX, I'd do my repair and cleanup work first, then I'd apply loudness normalization before exporting the audio into my DAW. Since I'm doing all of my work in my DAW these days, the loudness normalization step is the first step that occurs when I bring audio in. My goal here is to bring the volume up to a reasonable working level that gives me ample headroom so that I'm not clipping and I don't have to worry about noise. So I aim for somewhere between -21 and -23 LUFS, and I believe that Hindenburg defaults to -23. The first real step, though, is always going to be to assess the audio. How can we make it sound better if we don't know what it needs? Some assessments can be made by spot checking the audio and listening for things like plosives, mouth noise, sibilance, noise, and reverb. Other things can be assessed with software. For instance, a loudness meter or RX, it can scan your audio file and tell you how much dynamic range there is, how loud the file is, and whether there's any clipping. The more you do this, the faster you'll get at assessing the audio. And once I've assessed it, I now know what the audio needs. This is when we make repairs to the audio. The most common issue that falls into repair work in my eyes is clipping. Once we've made our repairs to the audio, if it needed it, we shift to the cleaning up phase. And these are the types of tasks that I tend to associate with cleanup: noise and reverb reduction, mouth noise, plosives. I tend to address them in that order. Noise and reverb reduction tools tend to work best before we do any additional processing. So that's my first order of business when working with a dialogue track. I typically use a Sentai's DX Revive Pro and Supertone Clear for these tasks. Not everybody has mouth noise. I know I definitely do, but if they do, it's the second step of my cleanup phase, and I haven't found anything that cleans this up more or better than Isotope RX's mouth declick module. Lastly, I'll address any plosives if I hear them during my spot check. And it's kind of easy to miss plosives when doing spot checks, so this is one of those things I might turn on as I'm editing and making small tweaks to my mix. And that's one of the reasons why I do set up my mix first, because I want to hear it in its entirety. I want to hear what the listener is going to hear as I'm editing, so that if I need to tweak something, I can do that in real time instead of having to go back and listen through it a second time. RX's deplosive module, it works well enough, but these days I find myself using Sonible's de-ess for it, because it handles not only de-essing, but also deplosiving, removing plosives, however you want to phrase that. Once I've cleaned up the audio, it's time to move on to the frequency balance. The most obvious tool here is EQ, but I do like to de-ess before I EQ. The reason for this is that I'd prefer to have the sibilance handled beforehand, so I don't have to be as aggressive with the EQ. And when I apply EQ during this phase, I'm only cutting, with kind of a focus on any frequencies that are overly dominant or poking out. I'm not a big proponent of additive EQ because it really kind of requires having good monitoring and some skill, or it's too easy to take good audio and make it unlistenable. And there's one exception to this rule for me, and that's if you're using Sonible's Smart EQ. It does a really good job of EQing the audio for you, and I'm not sure if it's using AI or machine learning, but it uses that kind of technology to identify what the audio recording needs, and it takes the guesswork out of EQ. Once the frequency balance is good, I move on to dynamics. And by dynamics, I'm talking about the changes in volume as the person talks. A really dynamic speaker is someone who goes from really quiet to really loud, and this can make it challenging for the listener, especially if they are listening or watching in a loud place. Noise can make the quiet parts inaudible, or the listener might feel like they have to keep adjusting their volume to be able to hear everything because it cycles between quiet and loud. There are two common tools to help us control the dynamics: levelers and compression. I like to use both of these. Levelers, on their own, can be a little bit fiddly. Some of the adjustments can be a bit too much, so I find that running a compressor afterwards can help smooth them out. In my case, I'm using Sonible's Smart Comp, which handles both tasks all in one plugin. Compression works by reducing the volume of the louder bits. It doesn't make quiet parts louder. It actually makes things quieter. So we'll use makeup gain to boost it back to the same volume it was before we applied the compression. Applying makeup gain is what actually makes the quiet parts louder, not the compression itself. And one thing to note here is that when we increase the volume with makeup gain, it can make quiet noises louder. So noise that you might not have been able to hear before, or maybe some quiet breaths, the makeup gain will make those sounds louder too. So there's always trade-offs when we start processing audio. So you'll need to use your ears and judgment to make decisions on where to set things. And this goes back to that idea of there being no set rules and sometimes having to make compromises. In my case, I choose efficiency over ideal and best because sometimes good enough is all that we need. Using AI and machine learning powered tools, they can be great ways to save time on the mundane work. While I feel the tech isn't there yet for text-based editing, I've moved to an almost entirely automated mix using Sonable smart plugins and I guess, the new generation of noise and reverb reduction tools. I estimate that these workflow changes they probably save me about 10 to 15 minutes per track. So they help with efficiency. Now we're moving on to the last step, which is actually the same as the first step. Now that we've cleaned up and mixed our audio, we need to bring it up to level. There are two methods you can use for this: limiting and loudness normalization. Since I prefer to hear my mix in its final form as I'm editing, I use a limiter on my master track, or I guess my master output, stereo output, main track. There's so many names for it, but I use that to bring the volume up to my target. This eliminates any kind of nasty surprises that may show up if we're applying loudness normalization blindly to a kind of a quiet mix. And it shouldn't be a surprise at this point that I'm using another Sonable smart plugin. This time, their smart limit. This one tends to need a little more adjusting than the other smart plugins, but since I'm running it as I mix and edit, I'm able to make adjustments as I go. So by the time I'm done, I'm usually within about a half lufs of my target. And speaking of targets, the standard loudness for podcasts is -16 lufs with a maximum true peak level of -1 dB. For YouTube, I wouldn't go any higher than this, even if they do recommend -14 lufs. That's just, at least in my opinion, too loud for Dialog. At the beginning of this video, I mentioned showing my default processing chain. This is where I start with every piece of guest audio, and this is where I start when I start working with a new client. Supertone clear for noise and reverb reduction, though I'll switch this out for a Sentize DX Revive Pro if it's audio that needs a lot of work or if clear just isn't getting the job done. RX mouth declick for mouth noise. This works on those gross inside of the mouth sounds, but it doesn't work on things like lip smacks or vocal tics. Sonable Smart de-ess for de-essing and plosive control. Sonable Smart EQ, Sonable Smart Comp, and Julian loudness meter for monitoring my levels as I go. The loudness meter it's a key for me for ensuring that all the Dialog tracks are at the same volume. I aim for them all to be within a half lufs of the loudest track in my session. And then on my master track, I have a Sonable smart limit applied there. And that's it. That's my recipe for processing and mixing Dialog. It doesn't matter if you're working with podcasts or a YouTube video. This approach will work for it all. If you're working with audiobooks or film and TV, that's a little more specialized and not really the topic of this video. What about you? Do you have any questions about processing and mixing your audio? What is your current process? What insights would you like to share? Let me know in the comments below. And I know this can be overwhelming. If you're still struggling after watching this video, I do offer one-on-one coaching, and I have a course available. There's ways I can help you out more. So look in the description for some links for my courses and scheduling one-on-one coaching and consulting. But otherwise, thanks for watching, and I'll talk to you next time.